welcome to the AI Club. And today we are starting a new course, full-fledged course in natural language processing. So it involves a lot of machine learning and as well as deep learning, both are involved. And apart from that, there are a lot of interesting concepts involved for processing the language. As you know that we cannot put strings into any machine learning algorithm, including deep learning or that LSTM, whatever you need to process NLP text, you cannot put strings. So you need to convert into some kind of numbers. String should be converted into numbers. So at the word level, so suppose there is a sentence called the AI Club by Shailendra Kadre. So it has 1, 2, 2, 4, and 6. So it has 6 words. So broadly speaking, these six words are called tokens. In our technical language, NLP language, they are called tokens. So I first break into my text, like whatever text I have, suppose I have one sentence or I have 10 sentences or I have 1000 sentences. So I'll break them into sentences, chunks and words. So those are my tokens. So I'll basically break them into smaller readable parts. That they are my tokens. Okay. So I cannot put these tokens into machine learning algorithm as we discussed. So the machine learning algorithm always needs numbers. So there are a number of ways to convert. These words into numbers. And whole game of NLP boils around how accurately you convert these words into numbers. Numbers means each word will be converted into a vector. Vector will contain numbers. And as you understand, each language, any word doesn't stand alone. It stand with respect to the context. It stands with respect to the context. Means whatever is the any word can have different meaning in different contexts. Right? We all know this. So in English language, if I use different word in different sentences or different contexts, so word may represent different meanings. Right? So we'll see examples as we go forward. So how accurately we represent this particular word with respect to its context is the whole game of NLP. Once you represent it into vector, word into vector, nothing. You just call the machine learning algorithm, just divide into extract and extract, and the usual machine learning processing. So there is nothing more than it's a 5-10 minutes job after that. But the entire game of NLP, for what we are studying NLP, is putting these words into proper context, proper vectors. So converting of word into vectors. So this is all is our NLP. Whole NLP game is converting the word like club by Shailendra Kadre. So each word should be put into a vector. And how accurately you represent these vectors with these words with the help of vectors is the whole game of NLP. So I think I repeated multiple times. So usually, classically, what happens? NLP usually starts with something called regular expressions. So if guys are familiar with, guys are from computer background and Himanshu, are you familiar with regular expressions? Yeah, so this starts with regular expressions. But regular expressions is some kind of coding actually, and it is some kind of cryptic codes. So you may not like it as a first lecture. But usually the NLP course starts with regular expression only. Okay. So you will ask then why we use regular expression. It is for pre-processing of the text. Like before we converted them into numbers, we need to extract proper words and those things from the sentences. We have to clean the sentences. We have to clean the text into proper format. So for all these things, we need regular expressions. So as we saw that Himanshu is from computer background, he already knows about regular expressions. So we'll be having a one full lecture on regular expressions. But I want to keep it simple today. So I will not start with regular expressions. So we will take up usual regular theory today. So this is I have planned the lecture for regular expressions. So we'll take it as second or third lecture. So today we'll plan something very simple. So I'll make my screen full size. Okay. So screen is visible, right? Hello. And am I audible also, right? I am audible as well, right? So great. So we natural language processing will plan 7 to 8 classes, not more than that. So first it is NLP, converting word into vectors. Till that part, there are number of schemes. Like there are many schemes of converting a word into vectors. There are some are very simple, just as simple as counting the number of words and putting them in a vector. So as simple as that, till we have some word vector which is called word embeddings. Word vectors are called word embeddings in technical language. So these word vectors are derived from complex deep learning models. So that they are called word to vec, glow scheme, GLOV, glow, word to vec. So these are the schemes which we use to convert by using very complex deep learning models. And there is something new has come up apart from 2017 or 18. Some new technology has come which is called transformer models. So there is a latest technology which is going on called BERT. So that technology is based on very complex transformer models. So that technology is also used to convert word into vectors. So you will ask that why such kind of complex technologies are needed. So it is because a word can have a different meaning in different context. If I use one same word in different sentences, it may represent different things. And especially in English, these things are very complex. Like one word can have multiple meanings. So when we are processing natural language, suppose we are doing some sentiment analysis. Sentiment analysis means we are collecting a tweet on a movie. Where a particular movie, say a THOR Thor movie is going on, right? This the THOR Thor movie is going on. So for that movie, if I collect all the relevant tweets from Twitter, and analyze them, which tweet is positive, which tweet is negative. Why I do that? So if positive tweets are more, then yes, naturally we are going in the right direction, and it is directly proportional to the money which the movie will collect in the box office. Okay, and if negative tweets are more, then definitely it is not a very desirable thing. So it is a very simple example of why we process natural language. So if we want to understand the tweet, whether it is positive or negative, we must understand any word in its context. In what context the word has been used. जिसको हिंदी में बोलते हैं ना, किस संदर्भ में वर्ड को यूज किया गया है. मतलब in what context the word has been used, that we should understand. And as a human, it is very natural for us to understand. No, we don't need any effort. But to make machine understand that, we need very lot of efforts. Machine needs a lot of effort to understand the whole context, in the context in which the word is used. So for that, lot of complex technologies like transformer technologies have been developed to accurately represent word in its context. That's what all the jugglery is in NLP. So today we'll today is a starting class. So we'll discuss a very simple scheme to convert word into vectors, which is just by counting them. How many times it has appeared in the sentence, or how many times it has appeared in the document. So we'll use that, and we'll see that how accurate interpretation can we draw. We'll use a simple classification model. So we'll have a tutorial as well, small tutorial, and very simple scheme we'll use. Right, it's a first class today. Okay, so these are the important topics. I don't. It's not important for you to familiarize. So, but most of things we'll be covering most of these. Like many of these topics we'll be covering. So this you can say that this is a collection of encyclopedia collection of topics which you can study in NLP. See in the third column towards the last you have chartboard transformers. So these things are the latest. Transformer is the trend these days for converting word into vectors, BERT, BERT technology, and there are a lot of other technology based on transformer model. So first what we'll do today? Today is the first class. So I named it as class 1 of 5. So what we will do today is we'll just understand some basic terminology which is related, some basic terminology which is related to NLP. So first of all, what topics we are going to cover in this class? So common NLP terminology, that's what we'll cover. Then we'll cover what are the components of any natural language processing analysis. Then we'll see the steps in natural language processing. Then there are 5-6 steps, out of which we'll study 2 steps today. One is lexical analysis and syntactic analysis. And then we'll study one important concept of tokenization. So I think you are now already familiar with tokenization, and we'll try to understand what are NLP stop words. What are stop words? There are some words which we remove from the sentence, like if you see the title here, topics to be covered here in this class. So to be in this, these are the very commonly used words in any sentence. See, mind it, to be. Maybe it may not be but two in class. Two in class, these words are very commonly used in every sentence. So these words hardly make any meaning value for us. They don't bring any value for us in analysis. So we remove this kind of words. So they are called stop words. So like to, in, this kind of are, a, this, that, has. So these kind of words are called stop words, commonly used words. So they don't add any value to our analysis. So we remove them from our analysis. Okay. So now we get into our understanding of terminology. First of all, we understand what are the basic terminology. So till this point, anybody has any questions? Himanshu or Sauji? Any question till this point? Okay, so we proceed. So there are two very umbrella terms of NLP, which is one is called natural language processing, and one is called natural language understanding. So natural language processing focuses on recognizing to understand the natural language, and natural language understanding is little more deeper. It focuses on meaning of sentence. So like in a simple term, you want to understand NLP breaks and processes the language, like breaking into part of speech, breaking into names and entities. So this kind of breaking up, breaking up and processing of language is called NLP. And if you go little deeper into that, which provide the language comprehension, means you want to understand the language, so that is called NLU. So these are very broad classifications, like very broad classification done, but in the strict sense they are not used. If you talk about NLP, it includes NLU as well. But generally these two broad classification are done on a academic level. But when we talk about NLP, it talks about understanding the language as well. But if you want to understand these two terms, there are two terms, NLP and NLU. So just try to look into these boxes, these circles. So natural language processing is more of a processing of language. So it will include something called name entity recognition, part of speech tagging, syntactic parsing, text categorization, machine translation, and maybe conference resolution. So these kind of things, many of these things will take up in today in some of the future classes. And NLU, like, it focuses more on the language understanding. So question answering. If you want to answer a question, you must understand what is asked in the question. So that's where understanding is involved. Then semantic parsing. So semantic parsing is one level advance of syntactic parsing. Don't worry if you don't understand these terms, because we are going to anyway take up these terms formally. Then text summarization. If you want to summary any text, like you are given 4 or 5 pages of text and you want to summarize it into say 500 words. So before summarization you have to understand. So the understanding is involved. Sentiment analysis, similar thing. Sentiment analysis, simple. Suppose you want to classify sentiment into positive or negative. So you must understand sentiment first. What is written, you should understand. Conversational assistant, like your chatbots or your like iPhone Siri you have. then you have Cortana, many Google Assistant, then this Amazon Assistant is also available. So these kind of things, if you want to implement, first you should understand what is being spoken. Then only you can answer it, or then you can implement the task, right? So more of language understanding is involved in NLU. And then natural language search, like search also, like you should more of an understanding is involved. So these two broad categorization are done, but in corporate language, when you talk about NLP, it includes everything, both NLP and NLU. It includes everything, both NLP and NLU. So when we'll talk about NLP, we'll talk about NLU will automatically all these NLU things will automatically come into that. I mean, it's a broad convention. Okay. So now, next we get into more finer terminology. So vocabulary. So vocabulary, I think very common term you all are already familiar. Group of terms used in a text or speech. Group of terms used in text or speech. I think it needs no explanation. So bag of words. So bag of words is a new word which you need to understand. Bag of word means histogram of word within the text. So suppose I say like this is a class, and in this class Udesh Soman is logged in 2 times. So these are 2 sentences. So there are two sentences in this. This is Shailendra's class, and in this class Udesh Soman is logged into 2 times. So this is our sentence to be analyzed. So in this you will note that clearly this is repeated 2 times. So this is repeated 2 times. This is the first sentence also this is there, and second sentence also this is there. So we are counting the frequency of this. So similarly, we count the frequency of each word. We count frequency of each word. The word occurrence is taken on x-axis and frequency is taken on the y-axis. The usual histogram, I think. I think you are familiar with histogram with your machine learning background. So word occurrence will be taken on x-axis, and the count will be taken on y-axis. So wherever this will occur, so it will occur 2 times. So its bar will be 2 unit high. Okay, so this is the histogram. So bag of word is nothing but we count the frequency of word and note how much time a particular word has occurred, and we do it for all the words which are there in the sentence. Then another term is corpus or corpora, the collection of text of similar type. So corpus means on a particular topic, suppose you are collecting text, right? On a particular movie, suppose you are collecting all the tweets from the Twitter. So that we'll call as corpus. That will be a corpus. So corpus will be collection of text on a similar topic, like a movie review, social media post, on a particular topic, related post, related sentences on a particular topic. So they are called corpus. Corpora means it's plural only. Corpora means it's plural. And document. So they are body of text and collectively form a corpus. Like I have like a document is more or less nothing but the document what we use in our like day-to-day language. We use document. So you have a text document. So it may contain document can contain many sentences. So say a 5-page legal document. So legal contract. So a 5-page legal document is one document. And if I have a collection of 1 million such contracts, different contracts, 5 pages, 6 pages, documents are collected. So then it will call it corpus or corpora. Okay. So vocabulary, bag of words, corpus, and documents. So collection of documents is nothing but your corpus. Collection of document is nothing but your corpus. And we usually do our natural language processing analysis on a corpus. So we are given a corpus and we need to analyze that corpus. So we divide it into documents, then we divide it into sentence, and then we divide into words. So like that, tokens we divide them. We further subdivide them for further processing. So in this, I think things are very pretty clear. Vocabulary means simple group of terms used in a text or speech. Bag of words. Bag of words is nothing but the histogram of words. We count the frequency of words. And corpus is nothing a collection of word on similar type. like a movie review or something, and documents is nothing but a body of text. And if we collect a lot of documents, then it forms a corpus. Okay. So if any question, anybody has any question, then and there you can stop me. Out of vocabulary. So vocabulary, out of vocabulary is very clear. If a term is not there in my vocabulary, which I explained here, then it is called out of vocabulary. Then pre-processing of the text. So what involves pre-processing of the text? So like remove unwanted text. Unwanted text means it can be like if you are having tweet, like if you are collecting tweets from Twitter. So like people use lot of special characters like hashes. People use exclamation. Then uh, people use question mark. Lot of question marks. So these kind of then some people use like a noise. So people will use 100 times, five 6 times. Will be repeated. So those kind of things. Then you have to convert. Uh, I think somebody has to go on mute. Actually, who wants to go on mute? Some noise is coming. Himanshu, are you on mute? ठीक. So then you have to remove unwanted text, which is noise from the text. So it is the first step of any NLP task. Like this is first text. First text. There are many data pre-processing steps. Right now, I am giving only one to keep it simple. Just to remove unwanted text, and maybe second step can be you want to convert all capital letters into small letters, smaller case, because sometimes people use some words in capital, some words in small, some unnecessary capitalization people use. So you may want to convert it into all uniform case, a smaller case. So that may be a second next. That may be a next text pre-processing step. Okay. So we can, as we go along, you will get to know more pre-processing steps. So right now, to keep it simple, let us put it only to. We are removing unwanted text or noise from the unwanted text or noise from our corpus, and then or we are just converting from caps to a uniform case. So right now, let us put only those steps. There are more steps which we'll come to know as we go along. Then tokenization. So tokenization is very simple. Tokenization, like I would like to give an example of tokenization. Not included here. So tokenization, like see in the title, if you see common terms used in NLP, 3 of 6. 3 of 6. Okay. So what can be tokenization? Common is a token, term is a token, used is a token, in a token, NLP is a token, 3 is a token, and off is a token, and 6 is a token. So simply speaking, it is breaking down into larger part to smaller parts. So I am having at the sentence level. If I am having, I want to break down into word level for further processing. So why we do that? We do it for easy readability and understanding. Then embeddings. So embeddings, which I explained, like each of these words, like if you have broken down them, you have removed the noise, you have properly done the capitalization, you have converted them into small letters, everything you have done. All pre-processing you have done. But still your text is in the text format, like your document or whatever corpora you have or whatever corpus you have, that is in the text format. You cannot put it into your machine learning algorithm. Before that, you want to convert it into a vector. Vector means some number form you need to convert. So that vectors are called embeddings. So as I explained you in the start of lecture itself, embeddings can be as simple as just count the number of words and replace that word with its count. That's all. So if a word is repeated 10 times, so it will be shown that like some article is written about Narendra Modi. So Narendra Modi in that particular document will be repeated at least 100 times. So whenever Narendra comes, you replace Narendra with 100 because it is coming 100 times. So you do it for all the words you do it with all the tokens. Same thing. So it is as simple as that. As simple as that. That just count it, replace the word with its count. So that's simple vector. Okay, so that's all. or otherwise you deploy some kind of methods like transformer methods to get into proper vector form. Embedded embedded can be done on a token level or a word level, or it can be also be done on phrases or character level. See, embedding your word, which word embedding means vectorization. You generally or what generally we do it only on token level or a word level. Word level or token level only we do, like mostly we do it on a word level or token level only. But just for academic knowledge, remember that embeddings or vectorization can be done at phrases level and character level itself, apart from words. But whatever analysis we will do here in this class, it will be the tokenization will be based on word level only. So that's what we are going to do here. Part of speech. So part of speech is a typical term used in NLP POS, part of speech. So they are the word functions like noun, verb. So if you read these common terms used in NLP. So Udesh, can you tell me which are the verbs and which are verbs and which are nouns in this particular sentence? Common terms used in NLP. So which are verbs and which are nouns? Error is okay. Used. Okay. So these are the. So when we recognize, we want to understand. Machine wants to understand a sentence. Means first it should understand the parts of speech, which is noun, which is verb. So sometimes same sentence can be used in verb sense and same word can be used in verb sense and same word can be used in noun sense. So that happens. We all know that happens in English. So all this your machine needs to know that if I am using this word here, it is used in noun sense, and somewhere down the line, down the document, I am using the same word. It is that's where it is used in verb sense. So these all things documents your machine needs to know before it understands the meaning of particular sentence. So that is what part of speech, converting into noun, verb, and all those kind of things. Part of speech tagging means tagging. You are tagging the simple sentence like as said. Said NLP is a noun. So I tag NLP as noun, and I tag NLP as noun. So I am doing part of speech tagging. So this is one of the pre-processing activity of my NLP. So this is what part of speech converting into noun word means. I am converting sentence into its constituent parts. What it made up of. Word is made up of noun, verbs, predicate, and many other components which we are usually taught in school. So if we convert a sentence into that kind of form, we call it part of speech tagging. Then next we have stop words. So I think now you stop words you really understand. So like Sauji, would you like to tell in common terms used in NLP 5 of 6? In this, what you can classify as stop words? Yeah, so in just this sentence, you please tell me what are the stop words. Common terms used in NLP 5 of 6, the title of our slide. What are stop words? No, it's okay, understood. Definition understood, Sauji, you are correct. In this particular sentence, tell me which are the stop words. Off is a stop word. There is one more stop word in this. Common, no. Here. Common terms used in NLP. Title of the slide. Yes, correct. Is it understood, Himanshu and Uddesh? So, unwanted words which are unnecessarily connectors, he, has, have, those kind of words. I will give a proper example of stop words to you in the letter. So, to stop words, I think you have understood. N-grams. So, n-grams is a term which will cover in very much detail. We'll cover it in the 4th or 5th class. So, n-grams is nothing but continuous sequence of n tokens. So, like suppose, like I'm considering 3 tokens at a time. So, common words 3 gram. 3 gram means common words used. Common words used will be 1 gram. Then I move it next. Then I use terms used in. Then next gram. Then I used in NLP. So like 3 at a time I am considering. Collection of 3 words. So I'll call it a 3 grams. Similarly, it can be 2 gram, it can be 5 gram, like that. So it is, for now you understand, continuous sequence of n tokens. So we have tokens like common terms used in NLP 5, 6, of 6. These are tokens, right? So if I take a continuous sequence of n tokens, so 3 gram means I am taking 3 particular words in one token. Sorry, I am taking 3 particular words in one go. So if I am taking in 3 particular tokens in one go, I will call it 3 grams. Just for now, this definition is enough. But later on, we will cover it in great details. Lemmatization and stemming. So, like I would like to tell with an example. Like here you see, first is your stemming. See, there are two kind of here different form of change are given here in this particular slide. So, first particular transformation which you see, that is called stemming, and second particular transformation is called lemmatization. So I want you to observe this and tell me the difference between stemming and lemmatization. What is the, observe this, what is the difference? Yes, I think you are right. So we change any word with the help of like ing, es, ed, er, like that. Many suffix we put, like ing is a suffix, es is a suffix, ed is a suffix, changer is another form. So what it does shortcut only. It will remove all the suffix, like it will remove ing, it will remove s, yes it will remove, then it will remove ed, then it will remove er. So we have told that particular software that it is particularly fed in that software that ing, es, ed and er are suffixes. So it will simply remove them. So it will convert into chang. So chang is nothing but nonsense meaning. It doesn't have any meaning. Still it has converted into change. But sometimes you see that it is very simple analysis. I am using just removing the suffix ing, es, ed, er, like that I am removing. So very simple. It will take lesser time for computer to process it, to convert from these all forms of change to chang. Very less time. Just remove suffix and put the whatever is remaining. It is not bothered whether that whatever is remaining will make sense or not. So this chang doesn't make any sense, right? It is not a word in English. It may be a name in Chinese, that Chang and all. It may be a name, but as a word, it doesn't make any sense in English. But lemmatization, sorry. So lemmatization does a bit of hard work. So what it does, it recognizes the word and takes the proper, convert into a proper base form, which is in the dictionary. See, so all these left hand side, chang, changing, changes, changed, changed, all these words are derived from base word change. So it will do more pain. Lemmatization is taking more pain to convert words into its base form. So it is doing a proper job. So it is, accuracy is more in case of lemmatization. Because if I supply chang to my machine will not be, machine or any human also, machine or human will not be able to make out any sense of that sentence. But if I supply change, I can understand that they are talking about some kind of change. Either it is changing, or it is changes, or it is changed, or it is a changer. But they are talking some kind of change. Some meaning it is giving. So it is giving more work. So when we want to do quick and dirty work with less processing, we have a very big corpora, like in billions of words we have, and computing capacity is limited and all. So we go for stemming. Stemming as a pre-processing step. So you see that it is a pre-processing step. Stemming is a pre-processing step. So we go for stemming. And suppose we have proper computing resources available, proper software available, then we do a proper job of lemmatization. So there are some modern libraries which are called SPACY, SPACY, SPACY. Those libraries by default don't provide any stemming. They give only lemmatization. They give only lemmatization. They're telling you if you are doing a job, do a proper job. So I'm not giving you stemming at all. Just go for lemmatization. But some older libraries are like NLTK. So they will give you both stemming as well as lemmatization. So you can do one analysis with stemming, compare the result, and then you do one analysis with lemmatization and get the results and compare them if you want to do that. I have such a worked out example for you, so which I'll share with you, in which one analysis is done with stemming and one analysis is done with lemmatization, and accuracies are compared. So I think I need not take you through the terminology. So I think you already understand the difference now, because understand the difference. So this is what is the small difference between stemming and lemmatization. Now we get into, so these are basic terminology, and now we get into little more technicalities. So what are components of NLP? NLP means whenever we talk about natural language processing analysis, one corpus is given to us of 1 million sentences, or some group of tweets is given to us for sentiment analysis. So that processing, if we do, what are steps we want to take? So these are the steps: morphological analysis, pragmatic, disclosure integration, syntactic analysis, and semantic analysis and syntactic analysis. So in this next lecture, or this lecture will take up syntactic analysis, and before that there is one step called lexical analysis. So today we will take up lexical analysis and syntactic analysis. Rest all these things are more related to the understanding the meaning of the sentence, like semantic analysis and pragmatic and all. So they are related to understanding the meaning. So that will take up in the later classes. So today we'll finish syntactic and syntactic analysis and syntactic analysis and lexical analysis. So I take a, so these are the steps, step by step. First we do lexical, then we syntactic, then semantic, then disclosure integration, then pragmatic analysis. So you need, if you don't understand these some, don't worry at this stage. We'll anyway cover them in great detail in later classes. So these are the step by step, like it is a waterfall model. After syntactic, after lexical, only you can go for syntactic. Like that you go. After syntactic, only you can go for semantic. So this is a better graph with steps in NLP. So input sentence, then you just have a look at that. Just I'm showing you like proper NLP analysis if you are doing, then how it is done. So in syntax analysis, you are putting a lexicon and grammar. So this just have a look. Even if you don't understand, it is okay. Then getting into little code mode, like if you want to read if you want to do any NLP, first you want to read the file, text file given to you, you have to read it. So file can be in CSV format, JSON format, or you can be scraping the file from a web. Scraping means you want to directly take out from a website. So these are the codes given here. So I am not getting into code right now. So one more view of lexical analysis and syntax. So we are taking up into, now we are getting into lexical analysis and syntactic analysis. So I'll tell you what it is. So lexical analysis and syntactic, as you say, it's a cycle. So lexical analysis, we prepare tokens and give to syntax analyzer, and then it sends request of token to lexical analysis. So lexicon of a language means the collection of words and phrases in the language. Very simple. Lexicon, it is collection of words and phrases. Any sentence is made up of words and phrases. So that collection we called as lexicon. Lexical analysis is dividing the whole chunk of text into paragraphs, sentences, into words. Like whole chunk of data which I have, a corpus, or that document I have, I want to divide it into smaller parts like paragraphs, sentences, and words. So that is called lexical analysis. So simply break it down into some smaller parts. Either you break down up to word level, or you break down it into paragraph, sentence, or paragraph or sentence level. So that nothing but if you are breaking down your Whole chunk means your corpus into your whole chunk of the data what you have regarding your text data. If you are dividing it into smaller parts, that is nothing but lexical analysis. So paragraphs and sentences. Either you can derive on word level, paragraph sentence level, or words level, or a combination of these. Okay. So usually we do a combination of these. So like what is the syntax? So syntax, any natural language like English typically follows a hierarchical structure. Like we may not be that great in English, but we still understand that any language like English or Hindi, even Hindi, follows a hierarchical structure. Okay, so hierarchical structure, the most basic building block is words. So I need not explain you what are words. Then phrases. So what are phrases in our NLP context? What are phrases? So words grouped together. Phrases are word grouped together without a subject or verb. So without a subject or verb, if I group together the words, but they are always put together only after dinner, waiting for rain to stop. So these kind of sentences which are grouped together, so there is no verb, there is no subject in this. Waiting for rain to stop. There is no subject, there is no verb. So these kind of sentence collection is called verb phrases. Collection of words without subject or verb is called phrases. Then next higher member is clauses. So clauses are groups of words that have both subjects and predicates. Like like the dog the dog barked at him. This is a complete clause. The dog barked at him. So it has subject also, it has predicate also. The dog barked at him. So these kind of sentences are called clauses. And when we combine many clauses together, then it forms sentence. So sentence is a collection of more than one clause. So I know that some of you might have not understood what is predicate. But this predicate thing, I think we learn in 8th class, 7th class or something like that, which our English teacher might have taught you. So note it down, note down the word, subject and predicate, and try to Google it when this class is over. What is subject and predicates, okay? So now we are getting into syntactic analysis. So that's why we are understanding what is syntax. So first we understood the hierarchy of any sentence. So most basic block is words. Then we come to phrases. So phrases is a collection of words without a subject or verb. So in a phrase, when we add the subject or verb, it becomes clause. A clause. Like the dog barked at him. It's a clause. And when we combine many clauses together, it becomes a sentence. So this is how is the basic hierarchy of your English language. So syntax, what is syntax? So what is syntax means we first saw the hierarchy. Then we are getting towards more formal definition. Syntax is a set of rules. Syntax. What is syntax? Syntax is a set of rules, principles, and processes that governs the sentence. That governs the structure of a sentence. I'll repeat. Syntax is a set of rules, principles, and processes that govern the structure of sentences. Like we saw, like words form phrases, phrases form clauses, clauses form sentences. So there are some kind of rules for every language, principles and rules. So which govern the structure of sentence. So we know that every structure has a subject and a predicate, or many more parts of there in a subject which we saw in our high school and all that. The sentence can be divided into many parts. So this kind of syntax of a sentence is called, governing rules are called syntax. Another definition of syntax I am giving. Syntax is how different words such as subject, verbs, nouns, noun phrases, etc. are sequenced in a sentence. Like verbs, nouns, noun phrases, and different part of sentences, how they are collected to form a sentence. So these kind of rules are called syntax. Okay. So then there are different part of syntactic categories given in the right hand side. You see right hand side, sentences, noun phrase is called NP, then determiner is called DET, verb phrase is called VP, and then propositional phrase is called PP, and verb is called be, and noun is called an. So I think this is all deep. It is taking us into very deep into language actually. And if you want to understand NLP properly, at least you should understand what does it mean. So in this class, it is not possible for me to explain you what is a noun phrase or what is a determinant, because otherwise it will become an English class. So I'll share this PPT with you. So this predicate and subject, here you might have not understood what is subject, what is predicate. Here you might have not understood what is determiner, what is a verb phrase, what is a prepositional phrase. This you might have not understood. So I will leave it to you that after this class, when I share the PPT, these particular things you should Google out. So these are nothing but the different constituent elements of a sentence. So I think you got an idea on syntax now. Then there is something called syntactic parsing. Parsing, in a like any code written in C or code written in Java. So compiler does the parsing first, right? So similarly, before NLP analysis, any sentence is parsed. So see here the sentence, you see the sentence is, you don't see the tree in a whole right now, just see the sentence. I drive a car to my college. That is the sentence given to us for analysis. Sentence is, I drive a car to my college. This is the sentence given to me for my analysis. So now I have done the parsing. Like I have applied some kind of NLP rules, I did some kind of code and did some kind of parsing. So after a syntax, after parsing, I get this kind of tree. So see, now then I say that I is a noun phrase. Then I say drive is a verb. Then I see as a determiner. Car is a noun. To is a proposition. My is a determiner. And college is a noun. So I think many things are clear to you. Now at least it is clear to you what is determiner and what is proposition. It is clear to you. So this kind of trees comes out of our analysis. And it is called syntactic tree, syntax tree. It is called a syntax tree. So this is the result of your syntactic analysis. I am not getting into code. Code will come to code later. But when we divide our sentence into these kind of things, noun, determiner, verb, noun phrase, then this is the result of our syntactic analysis. So you note down the word, I drive a car to my college. This is my original sentence. And when I draw a syntax tree, how it looks like. So it is pretty clear. So this is the result of our syntactic analysis. So what we have done, grammatical rules are applied to categories and group of words, not individual words. So like we have applied some grammatical rules on this sentence and divided it into its grammatical parts like noun phrase, determiner. All are its grammatical parts. So that's what we have done. So, and one more thing we are telling that grammatical rules are applied to categories and group of words. So this is something which we will encounter later. So it is being told that the grammatical rules are usually applied at the group level, group of words and not individual words. Yeah, so if we have to apply grammatical rule, if I write just one word, so what rule you will apply? So if you want to apply grammatical rule, you need at least a sentence, right? Like I drive a car to my college. So this is a sentence. Then I can apply grammatical rule and find out these things, which is noun phrase, which is verb, which is determiner, which is preposition. Like that I can find out, right? And so I think you got the idea. Like if we do syntactic analysis, so this is the kind of output of syntactic analysis. So then this is another form of representation. Sentence is, the dog saw a man in the park. The sentence is, the dog saw a man in the park. This is the sentence. Then when I do my syntactic analysis, this is my coded sentence. So N is a noun, DET is a determiner, V is verb, and P is preposition. So I have divided park is, say, note down that D is a determiner, dog is N means noun, saw is V means verb, A is a determiner means DET, MAN is a N, and IN is a preposition, and then T is a determiner, and then park is again noun. So I divided into, so this kind of tree is seen. Now you might get little like worried that if I need to draw this kind of tree for every sentence, then it is done for I don't want to learn NLP. So don't worry, all these kinds of trees are drawn automatically, and this view also is a computer generated view. So like your NLP libraries which are there with Python will generate this kind of view. They will automatically do this kind of analysis. So you need to only understand it. You don't need to draw this kind of tree anytime. So all will be done by automatically. All will be done by Python libraries. Okay. So this is the one kind of same thing. The same tree is there. Which this tree, and this tree are same, but it is just in a proper format for you to understand. N is written now, but what your computer will give? Computer will give in this format. D, T, N, V, NP. NP means noun phrase. PP means another code. VP means verb phrase. S is a subject. So like that it will give. So at least you should understand the how to decode these particular codes, like what is the meaning of NP, what is the meaning of PP, or at least you should know if I am in a confusion where this decoding is available. That's what you should at least know. So if I don't understand what is DET, you go back to that particular your notes or your that particular website and find out what is the meaning of DET. So this that much you should know. Then tokenization, I think you have already understood. So tokenization, like tokenization, I think I will not repeat now because we have there is a sentence called never give up. So never give up. If we do tokenization, you see in the last three, it has three tokens. Never give up, three tokens. So I think it is properly understood. Then why we do tokenization? I think that is also understood. As tokens are the building blocks of natural language. So tokens are nothing but building blocks of most basic building blocks of the natural language. Like in building while building our house, the minimum block which we have is a brick. A brick is a most basic block, right? So like word is a building block for a natural language. The most common way of processing the raw text happens at the token level. As we told discussed many times, before processing, do the starting of processing, will convert it into token level. Yeah, so this is a proper example which I wanted to show you. So text is the cat sat on the mat. The cat sat on the mat. Now simple tokens, you see the token. All these are tokens below. The cat sat on the mat. And even this dot full stop also is taken as a token. But when we do bag of words or when we do proper when we do bag of words and we do analysis, at that time when we form our vocabulary, at that time we remove these things. Kyle, sorry. So stop words, question mark, exclamation, all these things we remove by processing. We don't need it when we form our vocabulary. So we remove dots and this full stop, everything will remove. And can anybody tell in this sentence what are the stop words? Udesh, what are the stop words in this? Very nice. The is repeated 2 times. Okay. So these are our stop words. So this is just, if you don't understand right now, it is okay. So these kind of libraries are available for us to do tokenization. There is a white space tokenization, dictionary based, rule based, pen tree, Spacey, Moses tokenizer, subword tokenizer. So in this all category, I am just showing you which is available. But in this, what we'll do is Spacey, S-P-A-C-Y. It is a very prominent natural language processing library which we will use in our analysis. Spacey is a modern library, NLTK is an older library. So these two libraries we'll be using. But just to get a preview that so many are available to you. Okay. Then stop words, I think you have already understood. So I will want to give you an example of stop words, which I have complete list here for you. See, this list is given in the right hand side, so it is not readable. So I have given here that link also. So I have opened that link here. That link I have opened here, and where is that link? I think I need to open it again. Sorry. So I need to open it again. I'll open it. Okay, so these are Google stop words. Okay, so there are many versions of stop words. So this is your Google stop words from you should remove from your SEO. So this is an example from search engine optimization. So that applies to your any NLP analysis also. So a beautiful and complete list of words have been given here. So I'll show you that there are so many stop words in English. So these are the stop words. I will little bit make it smaller. So these are the stop words. See, so many stop words are given. Just have a look. Spend 5 minutes. I'll share this link anyway with you. So like these are the stop words. We may use these Googles or may use some other version. Some other versions are also available. See, all these are stop words. Himanshu, Himanshu, ठीक है? So these are all stop words. So I think you can have a look. Like these are need, necessary, nearly, near, ND, namely. So these are anybody, another, and see many are the stop words. Be backward, became. So these are the stop words Google is using for SEO. We may use some other like species list of stop words, but it is important for you to understand there are many stop words which are to be removed, and this stop word library is available in ready-made available in your like Python library. So just you have to you call that library and you have to say that from my text corpus, my first break into tokens. And once you break into tokens, you just tell code that use this stop word library and remove all the stop words from my code, from my tokens. So it will do the job automatically. Okay, so that's where we are, and I think we have come to the end of today's lecture. And I have a tutorial now, so I give a 10 minutes break. Tutorial is just 10 minutes tutorial. I don't want to send you today just with the coding. I without the coding, just a solid example also we have for today's class. So a 10 minutes break and then we'll assemble again for 10 to 20 minutes maximum. Example is very trivial, very simple.